Problem 510 says, from the standard molar enthalpy of combustion of benzene at 298 Kelvin, calculate the value of delta A for the process. Compare the value of delta A with that of delta H. Comment on the difference. The chemical equation corresponding to the combustion of benzene is given at the top of the screen. By calculating delta H, we can then calculate delta U, and using that with delta S, we can calculate delta A. The first step is to calculate the heat of reaction by subtracting the heat of formation values of the reactants from the heat of formation values of the products. We can plug in our heat of formation values, and we end up with a delta H of negative 3,267.4 kilojoules per mole. We can now find delta U with the expression delta U is equal to delta H minus RT delta N, and our delta N value in this case is negative 1.5 because we start with 7.5 moles of gas and end with 6 moles of gas. When we plug in our values, we end up with a delta U of negative 3,263.7 kilojoules per mole. We now need to find delta S by subtracting the entropy values of the reactants from the entropy values of the products. When we plug in our values, we end up with a delta S of negative 219 joules per moles Kelvin. We can now calculate delta A by setting it equal to delta U minus T delta S. When we plug in our values, we end up with a delta A of negative 3,198.5 kilojoules per mole. If we compare our delta A and delta H values, we see that delta H is greater in magnitude, and this is because there is an entropy decrease in the system.